Assalamualaikum warahmatullahi wabarakatuh and good day. This video is created for course MAT 25 for Program of Diploma of Civil Engineering offered by University Technology Mara. This video covers chapter 2, vector algebra, and in this video we will focus on equation of plane. We are going to look at the introduction for equation of plane. For example, if Q is any point on a plane with coordinate x, y, and z, and given that point P with coordinate x0, y0, and z0 is a point on a plane and the plane is perpendicular to a vector n. For example, vector n is AI plus BJ plus CK. Based on 2 points that we have, which are point P and point Q, basically we can produce one vector, which is vector PQ, and vector PQ are perpendicular with vector n. And based on vector dot product that we have learned previously, we can say that vector PQ dot with vector n will be equal to 0. For a quick recap, let's take a look at the scalar product or dot product for two vectors. So for example, vector A dot with vector B is equal to magnitude of vector A times magnitude of vector B times with cos theta. And if vector A and vector B are perpendicular, so vector A dot vector B will be equal to 0. By referring to the diagram, we can say that vector PQ dot with vector n equal to 0, and vector PQ is equal to vector OQ minus vector OP. And basically vector OQ equal to x, y, and z, and vector OP equal to x0, y0, and z0. For vector n is equal to A, B, and C equal to 0. And after we do the operation, we will get x minus x0, y minus y0, z minus z0 dot with ABC is equal to 0. And basically this is what we say as equation of plane. If we expand more the equation, finally we will get this one, ax plus by plus cz equal to d, where d is equal to ax0 plus by0 plus cz0. For the summary, if we are asked to produce one equation of plane, basically we need to have two things. The first one is we need to have one point located on the plane, and the second one is we need to have one vector that is perpendicular to the plane. We look at example 1. Given point A is 201 and point B is 410. So you need to find the equation of plane that pass through point A and the plane is perpendicular to vector AB. The information that we obtain from the question is point A, point B, and based on these 2 points, basically we can have a vector AB. Let's imagine that we have this blue plane, and basically point A is located on the plane, and also this plane is perpendicular to a vector AB. Basically we have all the informations that we need to produce equation of plane, which are one point that located on the plane where we have point A, and basically from point A we can have information for x0, y0, and z0, which is 2, 0, and 1. Another one, we already have one vector that perpendicular to the plane, which is vector AB. And then basically from this vector AB, we can get the value of A, B, and C, which is equal to 2, 1, and -1. The next step is we use back the equation of plane, and then we just substitute the value of x0, y0, z0, and also value of A, B, and C based on the point A that we have, and also based on vector AB. And after we substitute the value, the final answer will be 2x plus y minus z equal to 3. So this is the equation of plane for this designated plane. Generally, if we are given with equation of plane, we can determine a vector that perpendicular to the plane by referring to the coefficient of x, y, and z. So this value basically directly we can determine the vector that perpendicular to the plane. Now we move to example 2. Given point A is 4, -1, 0. Point B is 2, 4, 1. And point C, 0, 2, 0. And you need to find the equation of plane containing the point A, B, and C. So we imagine this blue plane is the plane that we need to find the equation, where this plane contains all the 3 points A, B, and C. In order for us to produce equation of plane, basically we need to have two things. The first one is one point that located on the plane. So based on information given in the question, so now we have 3 points that located on the plane, so more than what we need. And another one is we need to have one vector which is perpendicular to the plane. So basically from the 3 points that we have, A, B, and C, we can have vector AB and we can have vector AC, but these vectors are not perpendicular to the plane. In order for us to have one vector that is perpendicular to the plane, so we need to apply vector cross product. For example, here if we have vector A and we have vector B, so the product of A cross B, basically we can get a vector n, whereby this vector n are perpendicular to both vector A and also perpendicular to vector B. By applying vector cross product, we can determine the vector that perpendicular to the plane. And this vector are basically the product of vector AB cross with vector AC. By applying the formula for vector cross product, we can determine the vector that perpendicular to the plane, and we name it as vector n. And the answer for vector n, which is perpendicular to the plane, is -3i minus 4j plus 14k. And we use back the equation of plane, and let's say we are using the point A. We can have the value of x0, y0, and z0, and we replace and we substitute in the equation. And then based on the vector that perpendicular to the plane that we determined previously, we can get the value of A, B, and C, and we just substitute in the equation. So after we substitute, the final answer for equation of plane for this specific plane is -3x minus 4y plus 14z equal to -8. For example 3, given a line L1 and a plane P1, and this is the equation of line, and this is the equation of plane. And you need to find the intersection point of line L1 and plane P1. So basically we are using back the equation of plane, and then we substitute the value of x, y, and z based on line equation. And then after we solve the equation, we can get the value of t is equal to 4. After we get value of t, and then we need to substitute back in the equation of line in order to get the value of x, y, and z. And then you will get the intersection point is equal to 12, 10, 8. Lastly, for example 4, you need to find the angle of intersection between plane P1 and P2. And you are given with the equation of plane P1, and also you are given with the equation of P2. Let's imagine this is your plane P1 with the equation 3x minus 6y minus 2z equal to 15. And you have another plane P2 with the equation 2x plus y minus 2z equal to 5. And you need to determine the angle between the two planes. Let's say the angle is theta. And basically, we found that the angle between planes are equal to the angle between the vector that perpendicular to plane P1 and also a vector that perpendicular to plane P2. Vector that perpendicular to plane P1, let's name it as N1, is equal to 3i minus 6j minus 2k, and we can determine directly from the equation of plane by referring to the coefficient of x, y, and z. Next vector that perpendicular to plane P2, let's name it as N2, is equal to 2i plus j minus 2k. And basically we determine from the coefficient of x, y, and z from the P2 equation. In order to determine the angle between the two vectors, let's say we have vector A and vector B. So we can apply the formula here. So the theta equal to cos inverse vector A dot vector B divided by magnitude of vector A times magnitude of vector B. In this case, theta equal to cos inverse vector n1 dot vector n2 divided by magnitude of n1 and also magnitude of n2. And for vector n1 dot with vector n2, we get the answer is 4. For magnitude of vector n1, the answer is 7. And then the magnitude of vector n2, the answer is 3. We substitute all the value in the equation and we get the answer for theta equal to 79.02 degree. Thank you so much for watching the video. I hope all the students will get some benefit and enhance their understanding regarding the topic.